Good morning, students. Welcome you all in this computer application class, session 7, and we are proceeding for the third chapter. So, we are going to start our third chapter. And in last class, what we have done? In last class, we have discussed about variables, literals, operators, a little bit, and data types. We have seen how many types of data are available, means how many data types are available that we use in Java. We have also seen the memory structure of the computer. Now we will go one by one the data types. Okay, we will go one by one the data types. We will see in Java which kind of data types are available and what we use in our programming. So let's start with our data type. Data types. Data types are the type of data which is used in the programming. Data types represent the type of data. What program we write, the type of data is used in the program represented by the data type. And further detail we will see just today. We will see the first category of data type is there in Java, that is primitive. Primitives data type are the basic data type which are predefined with this defined memory. They are used in the program and means already defined a value, default value, and a memory, and the predefinition already have which kind of value it will contain, which kind of how much memory it will take, and what is the default value. This all are predefined. So they are called primitives. Under primitives, we have the first category of data type, that is called integer. Integer data type normally used for the non-fractional values. Integer data type, when we use in our program integer data type, so we can utilize non-fractional values for operations. Means when we have to use primitive integer data type, we will use non-fractional values. And what are the means other, you can say, categories of this data type? Under primitive, first is integer. Integer data type represent the non-fractional values used in the or data used in the programming. So in non-fractional values, or in the category of integer, some more data types are available. What are they? Those first is byte. Byte is a data type of integer primitive category. Byte is a data type of integer primitive category which is used to store the value in the memory for 1 byte. Its memory consumption is 1 byte. Is it okay? It is used for very small number that can take the value memory space up to 1 byte. If you have to use a little bit bigger number, so you will use short. Short is the another category of integer primitive data type which also use non-fractional values which takes a little bit more memory space equal to 2 bytes, and that can store a bigger data in the non-fractional form. For example, -10 +10, this kind of data. Next we have integer. Integer is the one of the most used data type under primitive category. Normally we use integer and it takes in memory of Java environment 4 byte. It is also a non-fractional data type which is used for basically a bigger range of values. Because that is taking the 4 byte of memory space. So much bigger values that can be stored. What is the use of values, we'll see in upcoming topics. Next, in this integer, last category is there, subcategory is there, long. Long is the data type that use 8 byte of memory space in the Java environment, for the Java environment, and this 8 byte can contain bigger range of values. If I will explain what is the value, how will you justify the values category, what are the categories of values, so you will come to know that in this 3 digit means plus 127, this is the highest range of values can be stored in the byte type of variable, byte type of values. If we want to use a variable of byte type, so this is going to store maximum value as 127, its final range. Next, if we are going to use a short value, so its final range is right from the minus 127 to plus 127, and its range is minus 32,768 to plus 32,767. This is the range value of short variables or short data types. If you store if you take any short variable and you want to store a value, so in minus you can go up to this range, and in plus you can go up to this range. After that, next value will not be accepted by this particular range, this particular data type. So same way integer is there, integer can store much bigger data. That slowly we will come through our programming, how much bigger data we can utilize in integer, how much bigger data can be utilized in long. So slowly we can come to know through our program. Okay, only one thing you have to focus, when it will be called byte, so you will keep in mind 1 byte. If it is called short, so you will keep in mind 2 bytes of memory used in computer. Integer 4 bytes of memory used in computer. Long 8 bytes of memory used in computer. So this way we can come to know integer primitive types of data by data types which are used for programming, for storing, for using non-fractional values. They can work on, all can work on non-fractional values. Clear? So this way we can use integer primitive types. Now we are moving for next topic. Under primitive, the next category is there, primitive. Next category is there, floating point. Floating point data type. Floating point primitive data type includes all the values, all the data which can be represented in the form of fractions. Got it? In the form of fractions as this or this. So how we use it, what are their types, it will be seen in later, just today only, in later topics. So how many points are there, how many types of data types available under floating point data type, primitive data type. So we have two kinds of floating point data type. One is float and second is double. These are two data types that is categorized under floating point primitive data types. These are two data types which are categorized under floating point primitive data types, and they are used for storing the value in fractional form, float takes 4 bytes of memory space for storing the value, and double take 8 bytes of memory space for storing the value. Clear? So this way we can use floating point. Floating point, if someone is asking how many types of data types are available under floating point category, so you will tell 2. And what are their memory structure? Float takes 4 bytes, double takes 8 bytes. Don't be impatient about these all. What is memory structure, how we will use, same thing is repeating. Earlier I have told you this fractional, non-fractional, so why again it is there? Don't worry, let come the next topic, you will be very clear with this topic why these things are necessary for you. Next, after this, next category is there, character. Character, primitive, data type. Character primitive data types are again from the primitives category, and they include the data types in our program CHAR. Char. This is small letter CHAR. This utilize 2 bytes of memory space for the programming for a variable. Means in Java environment we use char, so it use 2 bytes of memory space for per character. Got it? Char representing one character that is written in single inverted comma. So it is going to take in the memory 2 bytes of space. So this is again a primitive type. This primitive type is represented with the help of char, and it takes in the memory 2 bytes of space. Next, under primitive category, next data type is Boolean. Boolean is the next primitive data type that is generated with the help of keyword Boolean. And Boolean takes how much space in the memory? You have done work in 8th class. It takes 1 byte of memory space. Means when you use a Boolean value, Boolean means true false value, and you have to create a variable of Boolean type. So it will take 1 byte of memory in the memory area. 1 byte of space in the memory area. So this way, this is the small structural representation of, you can say, primitive data type. So we have all primitive data types in just seen. After that we will see how these primitive data types will be used in the programming. Before that, one very important thing is there. All primitive data types have some default value. So again I am going to introduce all the primitives with the data types, with the memory space as well as their default value. So see, starting from byte. Byte takes 1 byte of memory space in the memory and its default value is 0. Next, short. Short takes 2 bytes of memory space and its default value is also 0. What is default value? Don't be impatient. I'm telling today only. Just after this. Integer takes 4 bytes of memory space in the memory and its default value also is there, 0. Then long takes 8 bytes of memory space in the memory. Its default value is also 0. Is it okay? Next, it is written 0L. This way it is represented, or 0L, a small letter it is represented. That makes the difference between integer and other data types and long. Long contains bigger space. That's why big value can be utilized. Suppose we have to use, for example, a mobile number for someone, for some programming purpose. So that mobile number can be saved in such kind of variables. Is it okay? Such kind of data types. Next, float. Float is the data type that use 4 bytes of memory space, and its default value is 0.0f. F is going to represent the float. Next, double, D-O-U-B-L-E. Double use 8 bytes of memory space, and this default value is also 0.0 D. D is representing double. Next, char is there. Char use 2 bytes of memory space in the memory, and its default value is null. Null we have already introduced. What do you mean by null? Or it is represented by or. It is represented by this default value, either null or this is the default value of character data type. Now, Boolean. Boolean use 1 byte of memory in the memory, and its default value is false. Is it okay? So this is the structure of primitive types that is going to represent all the primitives and their default value. Now here is question, how we can use it? Why we will use it? Is it okay? Now focus on this point. If you have not focused, you have just written this all in your copy, not written, not focused, no problem. But now you have to focus on the next point that is going to clear you the use of these primitives in our program. Clear? Let us start. Now you have seen when we are doing programming in Java. When we are doing programming in Java, so what we do, see, normally we take integer n equal to 0. This we take. This is the line or statement that is going to give you multiple ideas. In tokens we have seen separator, delimiters, after that this is what? Literal, this is operator, this is variable, identifier, and this is the data type. So if you take this line, so we can categorize this line in multiple parts as we have seen in earlier classes. This is called data type. Data type. This is called variable name. Variable. This is called operator. Because I have not introduced operator, which operator? So you just understand this is an operator which name is assignment. Next is constant. Suppose I have given here 10. So this 10 is going to represent a constant, and this is the separator. So this way, one line now is very clear for you all if you have learned from earlier classes. So these all terms now you can say identifiable for you. You can easily identify these all terms. Now see, separators going to separate this line from next line. Next, a constant, that is the default value of the, that is the given value of the variable, initialized value of the variable. Operator, that this is the assignment operator, means right hand side value will be given to left hand side because of this operator. We'll see in the operators category. Next, n is a variable name or identifier of a variable. Next, a memory space. Next is integer, that is our data type. Now question is there, all terms are clear for all. Now I'm going to remove it. Suppose in this line we are writing a Java program, because you have seen the coding in 8th class, so I'm writing very small program that you can easily get each step. This is a small program that contains one error that I know, and you can also recognize the error, what is missing here, that is the error. If I say, okay, this program let execute on the computer, so what happens, what Java thinks, how Java perform the error in front of a C. This is the class name, no problem, class is identified. This is the variable method name, method is identified, no problem. After that, when comes here, so this A is going to represent a memory, and that memory will contain 10. But question is that memory will contain 10. What will be the size of the memory? How you can know that this A can store this 10? Are you getting my point? I'm telling with a practical example. There is a classroom. Understand? There is a classroom, and classroom is made for 50 students in prior. It is already defined. Class 9th A is made for 50 students. Now tell me, can there only 50 students sit there? Can 55 students be adjusted there? If only sitting is made for 50 students, there will be problem. Other 5 students after 50 will not be able to adjust in the class. Strictly it is a complete environment for 50 students. Okay, one more time. So one class which is defined for 50 students cannot contain the number of students more than 50. Clear? Same way, if we are taking another example, one class is there which is not defined. How many students can sit? 20, 50, 30, 100, 200, not defined. How many students can sit there? What will be the structure of sitting there? Is there number there? How many students can sit? Which is not predefined. So when it is not defined, to the number of students may possible, 1 can sit, 2 can sit, 3 can sit, 30 can sit, 35 can sit, 40 can sit, 100 can sit. This is the drawback when no definition is there about a class. Ki class is containing 50 students. Class 9th is going to contain 50 students. 50 sitting is there. Class 9th B is going to contain 45 students. 45 sitting is there. So if no definition, no sitting is there, how many students can be there, how many can be adjusted, this is in doubt. Same way what happens when we are going to define A and giving this value 10. So A is not sure in the memory how much space I will take. A is not sure in the memory how much space I will take. What will be my space data type? Means if I remove this all line, question is means if I remove this all lines and I focus on this one line, So this one line is not going to define in Java. It is not like QBasic. In QBasic, normally we write the program C. In QBasic, what happens? Let A is equal to 10 CLS and print A. So it is going to print 10. In QBasic, there is a different methodology. That is a different language. In every language, there is a certain rule to use the values and variables. Values and variables. Here we need not to explain what will be the data type, what will be the memory use of A. But in Java, this structure is a little different. This definition is little different. If you are writing only A equal to 20, this is not giving full idea to the Java environment which type of variable is there, which type of variable, I am saying which type of variable is there, means which type of this variable is. This idea is not going to reflect. That's why, one more time, when we use the statement like this in Java, this statement will not execute. Why? Because we are going to store 20 here for A. A is required a memory, and that memory is assigned with the help of data type. Hope clear? If you are not clear, keep watching. See, this is our memory. When we write this statement, so this statement is incomplete because this statement is not going to define what will be the size of A. Have I written here what will be the size here? No, I am not written. Have I written the type? What will be the type of A? A will be a fractional type, A will be a non-fractional type, A will be a Boolean type, A will be a character type. Have I defined here? No. So how a variable get this definition? If I remove this part. And students, you focus on only one part. That is, suppose I am writing A. I am going to use this variable. Tell me about this variable. Is this going to give you any idea which type of variable it is, which type of value we can use in our program, which kind of, how much memory space it will take? No. It is the, you can say, variable which is not going to represent any prior definition. It will be an incomplete variable till we are not writing in front int. What is int? Not int. From byte to boolean, everything whatever you have to write is going to give an idea for the variable. Now the definition of integer will be utilized by A. Is it okay? The definition of integer. What is the definition of integer? One more time. Integer says I will take 4 bytes of memory. So no problem. A will take 4 bytes of memory. Integer says I will hold in my memory, I will hold a non-fractional value. So no problem. A will also contain non-fractional value. So when this line is written, you focus on this point. When this line is written, you give this integer definition to the variable. You pass this definition, prior definition of integer, to variable A. Now A will behave like integer. Integer cannot be utilized. We cannot use this way. Integer equal to 20. Java will not accept it. This is a wrong statement. Because it is a keyword, it is predefined, and already we have seen predefined words we cannot use directly. Got it? So indirect use is what we have said. A will be as integer type. A will be as integer type. So A will be as integer type means A will use all the property of integer. A will use all the property of integer. That's why A will be integer type. Hope clear? Little bit clear? Okay. So that's why we will write this particular statement in Java. And this statement is going to represent an idea for you all. That is, A is a integer type. A is integer type variable. A is an integer type variable. A is a, suppose I write here, byte. And I say, what we will say, A is a byte type variable. Matlab, A will use the memory of the definition of byte. So here what will be written? Here will be written A is a byte type. Now if I write here short, so you can easily call A is a short type variable. A is a short type variable. Means all the definition of short will be applied by the A. Clear? So this way we can come to know a little bit of this data type. So data type this way is going to be used in the program. Primitives you have used from byte to Boolean, all you have used, and you have seen their memory structure, their default values, and their slowly we will see their values, how we will include the values with them. So suppose we are writing a statement. Now we'll go more clear for this topic. Suppose I'm writing from very starting, I'm telling you this is a memory. Suppose I'm creating a memory. This is a memory, and in this memory area, means in this RAM area, what happened? Suppose I'm writing my Java program and I have written float, float f is equal to 12.23f. This is the line that is going to perform two operations. Operation 1, this is called the declaration of a variable. Declaration of a variable. Whenever it is asked, what do you mean by declaration? So giving name. Declaration means assigning name. When we assign the name to a class, so it is called class declaration. When we assign the name to a method, it is called method declaration. When we assign the name to a variable, it is called declaration of a variable. So this statement is going to explain that f is a float type. F is a float type variable. Float type means the data type of f is float. So what quality of float is already defined? Float will take 4 bytes of memory. Float will contain the non-fractional means fractional values. So this will be utilized by f now. This particular line is called initialization of variable. When we assign the first value to a variable, initial means primitive value, first value to a variable. So while assigning means when we give this value, so this statement is called as initialization, or this procedure is called as initialization of variable, giving the first value, initial value of the variable. So this statement is divided into two parts: declaration of variable and initialization of variable. Hope clear with all these terms. These are the logical terms you will utilize many times in Java to keep learning one by one. Okay, now we will see this line. Suppose this, we are discussing about this f. float f. When this line will execute, in the memory, one f named area will be generated. Why it is generated? Because data type is given, and data type contains a prior definition that tells I will hold a 4 byte of memory, and in that memory I can utilize the fractional value. So it cannot utilize, it is needed a helper, it is needed a, you can say, duplicate. So helper is f. Now float says this is the memory area created, and what is the name of the memory area? F. And f now will use this float property as this memory area will be of 4 byte and will contain this fractional value 12.23 f here. Is it okay? Don't worry, I'm not going to end up here. I will explain with some more examples. Okay, one more example. Suppose memory is there. In the memory, we have written short, S-H-O-R-T, short P equal to 25. This is a short type variable. And what is the definition of short? Just today I have told, short will take 2 bytes of memory space and will hold non-fractional value, a small non-fractional value. So we'll take this P, will create a P named memory space in the memory because of this data type, and this 25 will be stored here. Got it? So this way, this data type is used in our program. Data type tell the variable that you are going to be used in the memory, how much memory you will take because of me, which value you will use because of me. Because of me means because of data type. So data type explains for this variable how much memory you will take, that is 2 byte, and which type of value you will use. This all are defined by this data type. Hope clear? Little clear? All terms. This is constant, this is variable, this is data type. Little bit clear for all? Okay, we have some variable related initializations, and we have to understand what types of initialization is there. See. Suppose we are writing a line, a statement, and this is written this way: integer x equal to 25. So what idea you will keep in your mind, that x is a integer type variable, x is a integer type variable which will hold in the memory 25. So I will explain through memory wise this way: x is a integer type, means 4 byte of memory is needed, and it will contain 25. So when it is written x system.out.p x, so this value, the value of this memory, this space is called here, and it is printed 25. Hope clear this statements? Okay, next is there now we are going to see some types of you can say operation over the variables. For example, suppose in front of you it is given integer x equal to 10, and you are set to print it. System.out.print, you have written x. What will be the output? Okay, I can guess you are telling 10. Exactly, you are correct. How it is possible? Because x integer type of memory is created, and in the memory what is contained? 10 is contained. What will be the size of memory? Obviously 4 byte. So in the memory area one space, small space is taken with the name x, where 10 is already stored because of this statement. Now we are going to print. So x is printed, 10 is coming from here to here, and it is printed. Now see next step. In the same program, we are writing x equal to x plus 5. Do you know what happens? This last value of x, that is 10, is called here. And 10 is called here, and it is given to again x. So 10 plus 5, it is coming 15 assigned to x. Do you know what happens? This 15 is overlapped on the last number. So this 15 will go as a new value for x. Now if I write system.out.print x, so you will get what output? 50. Use of variable. This is the use of variable. Variable means variable can contain multiple values. How? This way. Every time new value can overlap on the last value. Every time new value can overlap on last value. So I will give you one set of expressions. You will guess what value can be there in the memory space. Do you have the pen and copy with you? Okay, let us start. Suppose I am giving integer x equal to 25, and I said integer x equal to x minus 5. Then I said x equal to x into 2. Then I said x equal to x plus 5. And lastly I said print the value of x. Can you calculate this expression, set of expression, and find the last value? What value will be printed after execution of these statements? Can we? Okay, let's do. Those who are able to, they will continue. Those who are not will watch here and match your answer after this. See, first value of x. A memory area is created with the name x, and here 25 is kept. After that, this statement executes. So this statement says 25, that is the last value will be called here, will be minus 5. So new value of x becomes 20. This is kept in this memory space. Now new value is 20. After that, this execute. This says 20 into 20. Where 20? Last value of x is 20. Now it is coming 40. And this 40 is given to again x. So x says now it will be overlapped, and new value will be 40 now. After that, what happens? This line executes. This line says call 40 here, this last value of x. And after that, plus 5 is added. 40 plus 5, how much it is? 45. This is the new value of x. Now it will be overlapped, and it is kept here 45. And when you are finally printing, so your output will come 45. This way we will get the value, or will get the new values over the variables. I hope you all are able to do this. Clear? So this way we can perform the variable related operation. We can understand the use of variables. We can understand the use of data types. Clear? Next, move to the topic. Okay, so next we have the topic that is called symbolic constant. There is a condition when we perform the operation on variable, like we are writing integer x equal to 10, and in next line we have written x equal to x plus 5, and after that we are printing system.out.print. So your result would be, expected result would be 15. Do you know how? This x will be called here with the last value 10, and now it is added with 5, and new value of x becomes 15. This will be printed here. Clear? Now question is there, suppose I want to make this 10 fix for a purpose. I give you one idea. I am making a software or program where I have to use a variable which will contain a value which will be fixed for all other values. For example, in the school, suppose I am making a school program, and all students I have to give a school code. School, not their admission number, school code. Suppose school code is there, UP 502. One school code is given by council. For example, if this particular value I want to fix for all students of the school and want to keep their records, so this will be permanent fix. This will be a permanent record or permanent data for all students. Each student will receive this, the code of a student, code of a student, code of a school student, code of a school student. So this I want to keep as permanent, same value, a permanent value. In that case, we have the keyword final. Final keyword, which is also called symbolic constant, allows to make any variable's value as a fixed value, as a fixed value for further use. For example, if you watch in this program, integer programming segment, integer 15 suppose I have written this programming segment. If I will ask what will be the result, you will say obviously it will be 30. First result, first its value was 50. Now next value will be overlapped on the last value. So next value means last value, what is going to be printed will be 30. I want to fix this 15. If I am making any change in the variable's value, it should not be changed. So what should I do? What should I perform here? What operation should I perform here? What I will do, I will, before this means a statement, in front of this statement, I will write final. This keyword is used to make a variable's value as a fixed value which is not going to change by different operations. Means if I have written here final integer x15 and this statement is given in your examination and it is asked what will be the output, without making any calculation, you just watch this first value and you will write here this will be 15. This operation or change will not take place in the memory. Why it happens? Because you have said this integer is, this variable is going to a final, means fully final, means a constant variable. Constant variable. See, constant variable. This variable is not going to change its value. Got it? This kind of operation can be given as 1 marks question in your examination for finding out whether you have the idea about this working or not. Or you can be asked what is the use of symbolic constant or what is the use of final keyword. So you can explain this way. Final keyword is the predefined keyword which is used for making a variable as a constant. The value of variable is not going to change in the further operations where it is going to be used. So this way we use the final keyword in our program. So today we have seen data types. Today we have seen the use of variables. Today we have seen the use of final symbolic constant or final keyword. So let's today, this is enough for today. We will start the next topic, type conversion. That is a little bit lengthy topic. We will little bit you have so many calculations there, so I'm not going to start today. That will be in next class. So thank you for being with me, and please keep updating yourself, because these chapters are not going to be the part of a revision when the school will open. So please go with them, watch the lectures carefully and revise it. If you have any doubt, please revise and try to calculate, perform the operations on your copy. You would have the book. Please consider the book and follow the exercises, whatever solved exercises, unsolved exercises. Go it very carefully. Okay? And till next class, I will try to give you the notes for first and second chapter. Means in till next class, it will be uploaded on the school website. So keep writing with the notes in your copy, and please updating yourself. Thank you for today. Thank you for being with me. God bless you.